का टॉपिक क्या है? कल हमने इंडक्शन मोटर देख लिया था। इंडक्शन मोटर में वी हैव स्टार्टेड द वर्किंग प्रिंसिपल एंड वर्किंग प्रिंसिपल समझ में आने के बाद द लास्ट टॉपिक दैट वी हैव लेफ्ट यस्टरडे वाज स्लीप। तो वी विल स्टार्ट टुडे आवर टॉपिक विद स्लीप। तो यहाँ पे सब टॉपिक्स लिखा हुआ है ऑन द राइट हैंड कॉर्नर ऑफ द बोर्ड। अब यह सब टॉपिक्स में आपको आज जो जो टॉपिक्स कवर होंगे उसको हमने पॉइंट वाइज लिख दिया है। सो वी विल स्टार्ट विथ स्लीप, वी विल कवर स्लीप, देन द इम्पोर्टेंट टॉपिक विल बी रोटर फ्रीक्वेंसी, then rotor equivalent circuit, then equivalent circuit of the induction motor as whole, and last topic will be the comparison of induction motor with transformer. So इस तरह से आपके दिमाग में ये बैठ जाएगा कि हाउ टू कोरिलेट each टॉपिक विद each अदर। ठीक है, सारे टॉपिक एक दूसरे से कोरिलेटेड है, एक के बाद एक दूसरे टॉपिक सीक्वेंस वाइज में है, ताकि आपके दिमाग में ये सेट हो जाएगा कि हाउ टू ड्रॉ द इक्विवेलेंट सर्किट एंड फर्दर हाउ टू सॉल्व एनी न्यूमेरिकल बेस्ड ऑन इक्विवेलेंट सर्किट ऑफ 3-फेज इंडक्शन मोटर। आइदर आप आपके सेमेस्टर एग्जाम में हो या फर्दर किसी कॉम्पिटिटिव एग्जाम गेट या ईएस की तैयारी भी आप कर रहे हो, तो उसके लिए भी ये आज का लेक्चर यूजफुल होगा, इम्पॉर्टेंट होगा। सो लेट स्टार्ट विथ yesterday reviews about sleep. Sleep क्या है? So in the last lecture I have told you that so this is the, let's suppose that this is the rotating magnetic field and it is rotating with, किसी को कोई दिक्कत हो रहा है देखने में या व्हाइट बोर्ड पे किसी को कोई दिक्कत हो रही है?
No sir.
No
Let's
sir.
suppose it is rotating with synchronous speed. Okay, fine. In clockwise direction. So it is rotating with synchronous speed in clockwise direction. Now there is the rotor. We are taking the example of a squirrel cage induction motor. So rotor is a squirrel cage type. So these are the conductors. Now we know that whenever there is a relative motion between the magnetic field B and the conductors, there will be an induced EMF. So EMF will be induced across the conductors. So EMF will be induced across the conductors. So presently these conductors are at a standstill. Presently, or initially, you can say initially these conductors are at a standstill. The rotor is at a standstill, so conductor speed is 0. Initially, we can say that initially rotor is at standstill. Standstill means rotor रुका हुआ है. It means technically we can say that NR is equals to 0. Rotor speed is equals to 0. Take initially NR is equals to 0 and the speed of magnetic field is NS. So the magnetic field is cutting the rotor conductors at a frequency which is given by F. Take, so NS is related to F in this fashion. NS is related to F in this by this formula or in this fashion. This is the frequency of supply initially when the rotor is at standstill. So this is the frequency of cutting of rotor conductors by the rotating magnetic field. So this is happening initially. Now what happens when this magnetic field is cutting the rotor conductors? Then according to Faraday law of electromagnetic induction. क्या होता है Faraday law of electromagnetic induction? Faraday law of electromagnetic induction says that, ये क्या कहता है? ये कहता है, it says that whenever there is a relative motion between the magnetic field and conductor, and EMF will be induced across the conductor. So in accordance with this law, there will be an EMF that will be induced across the conductor, rotor conductor. So this EMF will be induced across the rotor conductors. Okay. Now the rotor circuit will be, if we see the rotor circuit, then we will find that the rotor circuit will be like this. So on the rotor, you will see when we draw the squirrel cage rotor, the squirrel cage rotor will be like this. The squirrel cage rotor will be like this. It's a hollow cylinder. There will be slots which are cut on the periphery, and rotor conductors are placed in these slots. So this is the rotor conductor. Rotor is there. Now this will be rotated along a shaft. It will rotate. It will try to rotate, but initially this omega r or nr is equals to 0 at rotor is at standstill. Now these rotor conductors are shorted at one end. So they are shorted with thick wire at one end. Let's suppose at this end they are shorted with thick wire. So they are diagonally shorted with thick wires. So this rotor circuit can be modeled as in this fashion. Let's suppose this is point 1, this is diagonal point 2. So point 1 is here, diagonal point 2 is there. This conductor and this conductor is shown in this fashion. This is the rotor conductor and this is the rotor conductor. At one end, these are sorted with a thick wire. So this becomes the rotor circuit. Now, EMF is induced. EMF, if this rotor is at standstill, this rotor is standstill, so NR is equals to 0. But these rotor conductors are cut by the rotating magnetic field. Rotating magnetic field is rotating at NS. Hence, this rotating magnetic field will cut this rotor conductor as well as this rotor conductor So an EMF will be induced across these rotor conductors. An EMF will be induced across this rotor conductor as well as across this rotor conductor. In one side, its sign will be, polarity will be like this. On the other side, its polarity will be like this. So summing up cumulatively, we can say that दोनों का अगर एड अप कर देंगे तो नेट पोलैरिटी हमारा ये हो जाएगा, इस दोनों पॉइंट 1 और 2 के बीच में अगर हम किरचॉफ्स वोल्टेज लॉ को अप्लाई करेंगे 1 और 2 के बीच में, so this is 1, this is 2. Now rotor conductors can be modeled by certain resistance, and 1 and 2, if we move on like this, let's suppose that this EMF is of value of E and this EMF is of value of E. So यहाँ से यहाँ जाने पर E होगा ऐड और यहाँ से यहाँ आने पर E होगा इस डायरेक्शन में ऐड. So the net value of EMF will be 2E. So this becomes your rotor circuit. This becomes your rotor circuit. Now this circuit is complete. It is having an EMF source of 2E and a path to carry the current. It will, once this is completed, current will start to flow in the rotor conductors. So current will start flowing across the rotor conductors, and it will complete its path. It will start flowing from this side and it will return back from this side. So this is the path of flow of rotor current. So this will start happening. Once the current is flowing in the rotor conductors. Now current has started to flow in the rotor conductors. Now once the current has started flowing in the rotor conductors, then there will be the interaction of magnetic field B and current flowing in the rotor conductors I. And we know that Lorentz force, we know that there will be a Lorentz force which is given by dF is given by I dl cross B. It says that what Lorentz force says that? It says that any current carrying conductor placed in a magnetic field, any current carrying conductor placed in a magnetic field will experience a force, and that force is given by this formula. So on all the conductors placed on the rotor, we will experience a force, and this rotor is mounted to rotate along a shaft. So on all the conductors which are carrying current, इसका diagonal on all the conductors that is carrying current, it will experience a force. It started to experience a force. Now the force will start acting on these conductors. The force will start acting on these conductors. Let's suppose the direction of the force will be, so direction of the force will be so these are the direction of the force. So this is a rotating body, so torque will be applicable, torque will be applied on this shaft, and this rotor will start rotating. So once it start rotating, the rotor speed will be equals to NR as the rotor starts rotating, So rotor now starts rotating. Okay. Once the rotor conductor is carrying current, it will experience a force, and because it is a rotating body, so it will start rotating. Now we have to find the direction of rotation. Yesterday also we have known that in which direction it will rotate. So simple, for finding the direction of rotation, so to fix the direction of rotation, the direction of rotation of rotor, we will take the help of which law? We will take the help of the most important, Lenz's law. So with the help of Lenz's law, we can fix the direction of rotation. So what Lenz's law says? Lenz's law says that Lenz's law, its statement is simple. Just you remember the statement like this, that the cause will oppose its effect, or vice versa. You can remember, either you remember this statement or you remember this statement. Effect will oppose the cause or cause will oppose the effect. Both statements are correct. Effect will oppose the cause. Now you must tell Lenz's law का और हम कहाँ पे यूटिलाइज करते हैं, कहाँ पर हेल्प लेते हैं. Tell me where we take the help of Lenz's law. इससे पहले भी हमने पढ़ा है, कहीं पर तो Lenz's law का हेल्प लेते हैं. Anybody please tell me कहाँ Lenz's law की हेल्प लेते हैं?
In finding force, mu naught Ni.
In which topic?
Magnetic field, sir.
और कोई बताओ? If you remember your electrical machine 1, so when we were dealing with the transformer, जब हम ट्रांसफार्मर को डील कर रहे थे, सिंगल फेज ट्रांसफार्मर को डील कर रहे थे, then in that case to find the polarity of primary induced EMF, or you can say induced EMF on primary side, वहाँ भी हम Lenz's law की मदद लेते थे. ठीक है? To find the polarity of induced EMF on primary side. So वहाँ भी हम Lenz's law की मदद लेते थे. ठीक है? वहाँ भी when you will go after the lecture is completed, you go through the book in the transformer topic and tried to see how Lenz law is useful in ascertaining or finding the polarity of induced EMF. Same thing is here also. The law or the statement of Lenz law is same in both the cases. The statement is simple: the cause will oppose the effect. So what is the cause and what is the effect that we have to first choose? So cause and effect का relation opposite रहेगा, ये हमें देखना है. So in this case, in three-phase induction motor, in three-phase induction motor, the cause and the effect. So effect is the rotation of rotor. Now, the rotor has rotated. Why? Because of torque. Now, torque has come into picture. Why? Why torque has come into picture? Because of. क्यों आया है पिक्चर में? Because of current in rotor conductors. Now, rotor में current क्यों आया है? Because of induced EMF across rotor conductors. देखिए बिल्कुल सीक्वेंस वाइज है, ईच एंड एवरीथिंग इज हैपनिंग इन अ सीक्वेंस. सो अब रोटेशन ऑफ रोटर हो गया है, रोटर हैज रोटेटेड. नाउ वी मूव फ्रॉम द रोटेशन ऑफ रोटर से धीरे धीरे हम एक एक स्टेप पीछे आ रहे हैं, बैकवर्ड्स. सो rotation of rotor has happened. Why it has happened? It has happened because of the application of torque. अगर टॉर्क नहीं अप्लाई होता तो रोटर रोटेट नहीं करता. टॉर्क कहाँ से आया है? टॉर्क हैज कम इनटू पिक्चर बिकॉज द रोटर कंडक्टर्स वर कैरिंग द करंट. अगर रोटर के कंडक्टर्स में करंट नहीं होता तो देयर वुड नॉट हैव बीन एनी लॉरेंज फोर्स एंड देयर वुड नॉट हैव बीन एनी टॉर्क. So it has come because the rotor conductors were carrying the current. Now how the rotor conductors were carrying the current? So rotor conductors were carrying the current only because the induced EMF across the rotor has taken place. अगर rotor के conductor के cross EMF induced नहीं होता तो सर्किट कंप्लीट नहीं होता और करंट उसमें फ्लो नहीं करता. Now, and why the induced EMF has taken place? It has taken place because of, can anybody tell me?
Magnetic field.
Because of relative motion between rotating magnetic field and स्टेशनरी रोटर कंडक्टर्स. इसको बहुत ध्यान से देखना है और एक एक लाइन और एक एक टर्म्स का मतलब है यहाँ पर. सो वी हैव टू गो इनटू द डीप मीनिंग ऑफ द टर्म्स एंड द कंटेंट्स रिटन हियर. बिकॉज ऑफ रिलेटिव मोशन बिटवीन रोटेटिंग मैग्नेटिक फील्ड एंड स्टेशनरी रोटर कंडक्टर्स. रोटेटिंग मैग्नेटिक फील्ड कहने का मतलब है कि द रोटेटिंग मैग्नेटिक फील्ड इज रोटेटिंग एट ns and stationary rotor conductor is having speed of 0. ठीक है. So the cause effect तो we have seen. cause and effect हमें establish करना है, cause and effect. So here we will be writing cause and here we will be writing in other effect. And both will be having a opposite relation. So cause is nothing. Cause is this relative motion. Cause is relative motion between rotating magnetic field and rotor conductor. This is the cause. And effect क्या है? Rotation of rotor. This is the effect. Now both are opposite to each other. Both should be opposite to each other. And both are opposite to each other. तो opposite कैसे होगा? Oppose क्या करेगा? ये जो effect है इस अपने cause को oppose करेगा. This is the simple statement. जो effect will oppose the cause. Now effect will oppose the cause. So effect, that is the rotation of rotor, will happen in such a way, so as to reduce the, क्या reduce करेगा ये? So as to reduce the
relative motion.
relative speed between rotating magnetic field and stationary rotor conductors. तो रोटर अब किस डायरेक्शन में रोटेट करेगा?
Anti-clockwise direction.
I haven't said
RMS
clockwise or anti-clockwise. किस डायरेक्शन रोटेट करेगा? अगर मान लो कि सी, let's suppose that this car is your rotating magnetic field. This car is your rotating magnetic field and its speed is ns in this direction. ठीक है? This is the road. Its speed is. Now this man standing over here, this man standing over here is the rotor conductor, is the rotor. Initially the rotor is having speed 0 and this rotating magnetic field is having the speed ns. Now I am saying that this man has to move in a direction so as to reduce the relative speed. So what should be the direction of motion of this man? क्या होगा इसका?
Opposite to
Same
the relative
direction.
motion.
In the
Same direction. It
Same
should
direction.
move in the same direction. तभी तो relative speed कम होगा.
Yes, sir.
हम जिसके तरफ जाएंगे, अगर कोई बॉडी ऑब्जेक्ट मूव कर रहा है और हमको उसके साथ उसकी रिलेटिव स्पीड को अपने साथ कम करना है, तो हमें उसके साथ या उसके डायरेक्शन में मूव करना पड़ेगा. ठीक है? तभी रिलेटिव स्पीड कम होगा. सो द रोटर हैज टू रोटेट इन द डायरेक्शन ऑफ द रोटेटिंग मैग्नेटिक फील्ड. इन अदर वे वी कैन अंडरस्टैंड दैट रोटर हैज टू follow the rotating magnetic field. ठीक है? Clear?
Yes, sir.
So
Yes,
this
sir.
way we can understand. Hence, the conclusion क्या निकला यहाँ से? So conclusion is that in order to reduce the relative speed so we are adding the conclusion. So in order to reduce the relative speed between rotating magnetic field, that is ns, and stationary rotor conductors, that is nr equals to 0. क्या कंक्लूजन निकला? The rotor will start rotating in the same direction as the rotating magnetic field, or in other way, or in other sense, rotor starts following the rotating magnetic field. क्लियर है ये? इसको आप नोट कर लीजिए. इतने whatever has been taught so far, you just try to understand and try to note it down. Having giving a pause of 2 minutes, you note it down each and everything. किसी को कोई डाउट हो तो you can ask. बहुत ही कॉन्सेप्ट से मैं लेके चल रहा हूँ, so that even if you study it after 10 से 12 दिन बाद भी किताब को पढ़ोगे with my notes, so you can understand each and every concept related with slip and 3-phase induction motor. So rotor is just following the rotating magnetic field, and rotor will try very hard to follow the rotating magnetic field. It will try to come very, very close to rotating magnetic field, but it will never match the speed of rotating magnetic field. Okay, once it will match the speed of rotating magnetic field, then the concept of 3-phase induction motor will be nullified. वो फिर मोटर नहीं रहेगा. It will stop working as a motor. So second conclusion is that what can be the range of speed of rotor for a given 3-phase induction motor. NR can be from 0 to NS. ठीक है? ये लिमिट होता है और इसको हमें याद करना है. When it is 0, we can say that the motor is at a standstill. Otherwise, it is rotating, but it will never match NS. The rotor will always be following the rotating magnetic field. It will never be equal to NS. It will never match NS. So it will never catch the rotating magnetic field. It will always be following the rotating magnetic field. So in all the cases, NR has to be less than NS. Clear? बोलो.
Yes, sir.
Yes, sir.
हाँ, अब यहाँ पे देखो. Let's just check the example of that diagram. When a man is following a car, just take the example of that. Now let's draw the car. So this is the car. आजकल तो बहुत अच्छे नए डिजाइन के कार आ गए हैं. So this is the car. This is your rotating magnetic field. Speed क्या है इसकी?
Synchronous.
Its speed
NS.
is NS
NS.
in RPM. Now this is the man. So first draw the man also. So this is the man. Okay. It is also moving at a speed. Now the speed of the man is NR, and its range is from 0 till NS, but it will never be equal to NS. So it will be moving. Let's suppose it is moving on a skate. Okay, on a skater. So it is moving on a skate. So it is following, it is trying to catch, it is always trying to catch this car. it will come very, very close to this car, but it will never be equal to this car, the speed of the car. It will never be equal to the speed of the car. So it will always try to catch. Let's suppose one boy is also here. Let's suppose that one boy is also here in this car. One boy, his friend is also here in this car. He is trying, he is saying that come, just come and catch me. But he is trying very hard. It will be never be catching. So in the from this person, or you can say that this person is always saying that come and catch me, but this person is unable to catch this person. So this person, the second person, in his view and from his reference, we can say that this is, suppose that this is man 1, this is person 1. So person 2 will be saying that person 1, from the point of view of person 2, person 2 will be saying that person 1 is trying very hard to catch, trying very hard to catch me. Me matlab person 2. Person 2, but always fails to catch, or always slip away, always slip away. That is the meaning of slip. That is the meaning of slip. Always slip away. This is the meaning of slip. So slip is that rotor always try to catch the rotating magnetic field, but slips away from the rotating magnetic field. When we sit at the rotating magnetic field, and from there if we see the rotor, we will see that the rotor always slips away from the rotating magnetic field. That is the meaning of slip. And mathematically slip is given by this formula. Slip is given by this formula. आगे बात स्लिप समझ में आ गया सबको? What is the meaning, significance of slip? Slip means
Yes, sir.
when we sit at the rotating magnetic field and we look at the rotor from there, we'll find that the rotor is coming to catch me, but it is always failing to catch me, so it always slips away from my side. That is the meaning of slip. So slip S is, mathematically it is defined as NS minus NR. This is the slip. Percentage slip means what fraction of NS it is. So this is the mathematical formula for slip. So you can note it down. This is the mathematical formula for calculating slip in case of 3-phase induction motor. So this is the mathematical formula of slip. Okay. So what could be the range of slip? If I say that NR is between 0 to NS, ये इक्वल भी हटा दो यहाँ से. हाँ. Then what is the value of slip? Slip का value क्या हो जाएगा? What can be the numerical value of slip? If from this formula, put it in this formula, you will find that slip is lying between from 0 to 1. This is the range of slip only for
Induction motor.
Only for 3-phase induction motor, and only for motoring mode, when it is happening as motor only. When the machine is utilized as motor only, the same machine can be utilized as motor as well as generator as well as in any other mode, but slip will remain 0 to 1 only for the case of motor. Okay, so slip is covered. Now come to the rotor side. come to the rotor side. Now you take two important, you draw or you take two important case. First case is, यहाँ तक कंप्लीट है, सबका दिमाग सही है, किसी को हैंग नहीं हो रहा है, ज्यादा
No,
कुछ
sir.
नहीं, ठीक, ओके
No, sir.
ओके फाइन. So case 1. Case 1 is rotor is at standstill. It means that, sorry, it means that NR is equals to 0. ठीक है? So in this case, we are going to draw the equivalent circuit of the rotor. Only rotor side. अभी stator side को हम नहीं कुछ कर रहे हैं. Stator, see, in any machine, we are having stator and rotor. Fine. Now, in the first previous lecture only, I have told you the stator is common. Rotor, we are having two different kind of rotors for three-phase induction motor. One is squirrel cage, other is slip ring. That is okay from the point of view of construction. Now, stator, we switch on the supply on the stator side, and there will be a rotating magnetic field in the air gap. Now, rotating magnetic field will be cutting the rotor conductors, and then EMF will be induced, then torque will be there, then rotor will start rotating. So we are seeing only the rotor at present. So rotor is at a standstill. Now at a standstill, we are going to draw the equivalent circuit of the rotor. So we are going to draw the equivalent circuit of the rotor in this case. ठीक है, तो इससे पहले कुछ चीजों को हम समझ लेते हैं. Now, when it is at standstill, so क्या क्या चीजें हो रही होंगी in the road across the rotor conductors. So see here. This is your rotating magnetic field. It is rotating at ns. ये true है, even if the rotor is standstill, ये होता रहेगा. Now rotor को हम दूसरे कलर से draw कर लेते हैं. Rotor is inside it and it is there at standstill. So NR is equals to 0. Even it is at standstill, the EMF is induced because of the relative motion. So EMF will be induced across the rotor conductors. Rotor conductor के across EMF induced होगा. Now, let's draw the rotor. Now this is the rotor circuit. Let's suppose that this is conductor 1 and this is the diagonally opposite conductor 2. So point 1 is here, point 2 is here. EMF is induced, so EMF will be induced across rotor conductor and across this rotor. These are the two rotor conductors. This is the rotor conductor, this is the rotor conductor, and it is short circuited with a thick wire on one side. So it is short circuited. EMF is induced. Let's suppose that this EMF is written as E0 for standstill. EMF induced at standstill. Now, this rotor conductors, conductor in any case will be having क्या होगा कंडक्टर में? Conductor in any case will be having some amount of resistance and some amount of reactance. Some amount of resistance and some amount of reactance. So to summarize as a whole, we can say that the rotor circuit is source of EMF E0. These two resistance are added. These two reactances are added as a whole, and this is the rotor circuit that is completed. So this resistance is known as R0. This reactance is known as X0. Now, since this is the rotor side, we will write 2. Rotor means see, you can write here 2. ठीक है, 2 यहाँ हम किस लिए लिख रहे हैं वो हम बताएंगे. So अभी यहाँ पर आप टर्म्स के नाम लिख लीजिए. What is E20? What is X20? What is R20? ठीक, इसका नाम हम लिख लेते हैं. E20 is rotor induced EMF at standstill. We can see our last topic to be discussed today. आज नहीं हो पाएगा तो कल डिस्कस करेंगे. Is the comparison or equivalence between 3-phase induction motor and transformer. Just like in the case of transformer, we have primary side and secondary side, and one was used for primary side in case of transformer and 2 was used for secondary side in case of transformer. Similarly, for 3-phase induction motor, one subscript or 1 is used for stator side and 2 for rotor side. Rotor can be seen as secondary side of a transformer. React. So please note it down. E20 is rotor induced EMF at standstill. X20 is rotor reactance at standstill. R20 is rotor resistance at standstill. One subscript is for the primary side of the transformer. Here we will use it for the stator side. 2 subscript is for the secondary side of the transformer. Here we will use it for the rotor side. So we can compare the rotor as the secondary side of the transformer and stator as the primary side of the transformer. So let the lecture be remain here only. We will start the fresh from tomorrow. The topic we will start from here onwards. We will see the formula for writing the rotor current at standstill, or you can say that I20 at standstill. The formula we will write from tomorrow lecture. Okay, see you tomorrow. Okay, bye.
Okay, sir. Bye, sir. Thank you, sir.
Okay, sir. Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you.